Carberp is a piece of malware that's actually been around since late 2009, kind of early 2010, and it's actually a banking Trojan with a lot of other capabilities. It's a fairly sophisticated piece of malware, and we've actually seen a lot of interesting activity with Carberp recently, and I thought I would talk about it in this video. And in fact, Carberp, as you might have noticed, has been in the news recently, and the reason for that is that, well, first of all, back in 2012, mid-2012, there were a number of arrests of various people who were involved with the development and design of Carberp, including some people who were involved at the fairly high levels. Now, what's interesting is that even though these arrests were made, somewhat surprisingly, we didn't see a downtick in Carberp. In fact, if anything, we saw more activity occurring with Carberp even after these arrests. I think that's quite surprising and quite ironic in many ways. The other thing about Carberp is that more recently, in 2013, actually in about June, there was some evidence that the Carberp source code actually leaked. In fact, now it's pretty clear that this source code is actually leaked. And as a result, people who are maybe enterprising enough can get their hands on that source code. And I expect that as people get their hands on it, as they understand that source code better, they'll be able to do more with Carberp. In fact, we saw this happen previously with a threat called Zeus. When the source code for that leaked, a lot of copycat variants were made, a lot of improvements were made to Zeus. I expect the same thing is going to happen with Carberp now that more people can get their hands on the source code. Now, actually, I do want to clarify that not all the source code leaked for Carberp. In particular, there was one aspect of it known as the rootkit, of which only part of the rootkit leaked. And in fact, at the same time, the rootkit in Carberp is actually the same as the rootkit used in another piece of malware known as Rovnix, and so that's an indication or maybe evidence that Carberp and Rovnix were developed by the same team of malware authors. Now again, Carberp is fairly sophisticated. In fact, up until its leak, it was advertised you could actually buy the source code for Carberp for about $40,000. That's actually a fairly hefty sum of money. But it goes to show you just how sophisticated this threat was. Now, obviously, if you are enterprising enough, you can get the source code for free. But there was a time where you would actually have to pay a lot of money for it. And it's advanced, it's modular, it's easy to customize by attackers. It employs botnet techniques. It actually employs a number of hardening and evasion techniques, code obfuscation, anti-removal, anti-antivirus, and things of that nature. And I'll talk more about that throughout this video. But what I want to maybe touch upon before I do that is talk a bit about what a typical Carberp compromise might look like. So what actually happens within a Carberp compromise is the attacker will first go and find a web server that's somehow not secure. So let's say there's a web server out here. And what they will first do is compromise this web server. And typically they will compromise the web server with something like a web exploit toolkit. And I did a series of videos on web exploit kits if you want to understand how those work in more detail. But what that basically entails is that the Carberp source code, or the Carberp, not the source code, but the Carberp application itself is going to be essentially hosted either on the compromised web server or on a web server that's pointed to by the compromised web server. But basically this web server is somebody's legitimate server that got compromised with some code, and the code that's now hosted on this web server includes exploit code for various vulnerabilities of applications that a user might be running. So for example, vulnerabilities might include those associated with, let's say, various Microsoft applications and PDF and so on and so forth. Now imagine you've got a user, and the user has a computer, and let's say the user's computer visits a particular website that has been compromised and that now hosts this malicious code. And this is some type of visit over the internet. So we have a user who has pointed his web browser to this malicious code. And the way this might have happened is orthogonal. This could have happened maybe via a spear phishing message, or via some type of social engineering or a watering hole attack, or something of that nature. Just in general, the attacker somehow tricks the user into visiting this website, which happens to be laced with exploit code, just like you would for a typical web exploit toolkit. Now, at that point, the user, if he's running an application that happens to be vulnerable and there is exploit code for that vulnerable application running on the web server, the user in turn is going to get compromised, or the user's computer is going to get compromised, and Carberp will be dropped on that system and executed. Okay. Now, when the Carberp threat executes and installs itself, it does have a few features which I think are worth noting. One of the first things it does is it uses a technique known as process injection. Okay, and process injection is just a mechanism by which a given software application can essentially co-opt another application to hide itself. So in this particular case, what Carberp actually does is it basically injects itself. It injects itself into a legitimate Windows process. In fact, it injects itself into Explorer.exe, which is a well-known legitimate Windows process. And if you are interested, the way that the process injection occurs within Carberp is it uses an API in Windows known as NT resume thread. And really all this means is that if anybody is looking at the process list, the list of actively running processes on a system that's been infected by Carberp, they won't see Carberp, but they will see Explorer.exe running. And what's really happened is that Carberp is running now in the process space of Explorer.exe. So even though Explorer is really running, or is what you think you see running, underneath, it's actually Carberp's code that's running. Now, because Explorer is a well-known Windows process, it is very common to see it listed among lists of processes that are running on a Windows system. So nobody's going to notice that something is wrong with that particular system. Now, in addition to doing process injection, our Carberp will include or installs what's known as a rootkit. And a rootkit is basically just a way by which Carberp can maintain a certain degree of persistence. It allows Carberp to essentially resume whenever the machine is rebooted. So it really ensures that the threat stays persistent on the system. And the way that persistence is achieved within Carberp is through the use of the Windows startup folder. So the idea is that the copy of Carberp is going to be put into the Windows startup folder. So whenever the system is booted up or started up, Carberp will start running automatically. Now, in addition, Carberp does try to hide itself, and it uses a number of rootkit-like techniques to hide itself. And in particular, what Carberp does is it hooks a particular API known as NT-query directory. NT-query directory. And the idea is that this API is hooked so that what effectively happens when this API is hooked is that it appears like Carberp doesn't exist, but in fact you can really think of hooking this API as providing a hidden directory or hidden file on the system at which Carberp is located. Okay, so really it's like a hidden file or hidden directory. And actually I did talk a lot about API hooking in my videos on rootkits, as well as in videos that I've done on man in the browser Trojan, so you can get a better sense of what is entailed when a piece of malware performs some type of API hooking. Okay, so once Carberp is on the system and it's kind of firmly entrenched on the system, one of the first things that it will do is it will connect out over the internet to a command and control server. So let's label a command and control server out here, or a CNC server, and it's going to communicate with this command and control server. And this is fairly standard operation for some type of a botnet or a bot infected host. Basically what will happen is when this CNC server is contacted, Carberp will provide basic system information related to the infection, and so on. And then the CNC server will effectively control the installation of Carberp. So for example, the CNC server can be used to pass things like additional plugins for more malicious activity or for protection. And in general, Carberp does have a modular architecture, so you can have plugins that can be added onto Carberp to enable or to implement various types of malicious functionality. So what kinds of malicious functionality exist within Carberp? Well, some of the plugins include plugins for doing data theft, so stealing passwords, stealing email passwords, regular passwords, account passwords. That also includes things like VNC passwords or VPN passwords, which is interesting because it's a sign that Carberp is not just used for consumer malware, but it is maybe used in the context of corporate espionage or more sophisticated attacks. In addition, the data theft also includes theft of information inside of web browsers. So for example, any saved web browser form data, FTP credentials, things of that nature are all stolen. In addition, Carberp implements what's known as a man-in-the-browser attack, and I did a series of videos on man-in-the-browser attacks, so I won't go into it in more detail, but effectively what this entails is that the browser activity of the user is monitored, keyboard activity is logged, screen activity is logged when a particular URL is visited, such as the URL of a banking site, and then all this information, these keystroke logs and these screenshots and so on, they actually are archived into what's known as a .cab file, a .cab file, and this cab file is actually transmitted to the CNC server via an HTTP request. All right. In addition to that, other information that's stolen, and this is maybe in the context of it being a man-in-the-browser attack, is that in general, Carberp will intercept any HTTP post requests made on the victim system. It's going to steal credentials from that request before they get encrypted, because once they are on the channel or the actual network connection, they typically sensitive credentials do get encrypted, but while they're still on the computer, when they're just being entered in, they are technically still in clear text. And so as a result, they can be stolen before they get encrypted, and they can be transmitted over the web to a CNC server. In addition, there's also a capability within Carberp to perform what's known as HTML injection, and this is a common functionality that's seen in a lot of man-in-the-browser Trojans, and that basically just means that Carberp is capable of modifying web pages that the user sees. That could be very useful in the context of stealing sensitive data, since sometimes, let's say you modify somebody's transaction with their bank account, they may notice something is wrong when they see that their bank balance suddenly went to zero. Well, Carberp is capable of modifying that information for specific banks so that the user never realizes their bank balance went to zero. Quite a nefarious piece of activity. In addition to that, Carberp also has a number of protection capabilities in place, capabilities to really hinder somebody from being able to detect it or being able to disable it. So in addition to the capabilities I mentioned, Carberp also will have a plugin to disable antivirus, and that's a very common functionality for a lot of malware. It also will try to disable other malware. And the reason for that is that usually when a attacker is able to infiltrate a box and get control over it, the last thing they want is for some other piece of malware to also get control over that box and for some other attacker to gain control over that same system. So interestingly enough, Carberp will remove some other malware that it sees while it's disabling antivirus software. So I think that's kind of a unique and an interesting capability. It's not that unique. We do see other malware instances perform these types of self-protection capabilities. In general, Carberp also uses another standard technique known as packing. Basically, this is a way to inhibit standard analysis or static analysis of threats by making them harder to read. It uses encrypted configuration files. It encrypts network traffic actually using different algorithms. So actually the more recent version of Carberp uses an algorithm known as RC2. It's a well-known cryptographic algorithm for encrypting data. Prior to using RC2, Carberp also used RC4 in some earlier variants. So in general, this is a threat, as you can see, that has a lot of sophisticated functionality. It can be used for stealing sensitive data, for stealing screenshots, for doing man-in-the-browser type activity, for perpetrating financial fraud, and that sort of thing. And what I would encourage you to do is, if you want to get a better sense for what a man-in-the-browser Trojan does, I would encourage you to watch my videos on that particular topic. But this is all I have to say about Carberp for the moment.